Hi friends, welcome to my channel. This is IIT Foundation Max channel and it is for 7th standard onward students and useful for all competitive exams. So let's start our video. So let's start our fourth chapter, that is exponents or indices. Exponentiation is repeated multiplication. That is, n times we repeatedly multiply a number means it is expressed as the exponents. This is used in the case of large numbers that can be expressed more conveniently using these exponents. Let B adding n times a number x. That is, n times a number is adding means x plus x plus x plus it is repeated n times. Here n times we repeatedly added a number means it is n into x. That is, x is multiplied with n. For adding n times a number, just multiply that x with n. If we multiply a number, multiplying n instances, a number x means it can be represented like this. That is x into x into x into etc. n times. These n times, that is the repeated multiplication, is expressed as exponents. Repeated addition is expressed as this nx and repeated multiplication is expressed as exponents, and this is called exponentiation. That is, n times repeatedly a number is multiplying. Here x is called base and n is the exponent or index. Exponent or index. This is the exponential representation. This is mainly used for representing a larger number in simple form. That is the use of exponents. Let let 10 raised to 4. This is nothing but 4 times repeatedly multiplying the number 10. Next is just minus 1 from the or subtract 1 from the exponent. So it is equal to 10 raised to 3. It is nothing but 3 times the 10 is multiplying. This is equal to 40 and this is equal to 1000. And it is nothing but the previous number. That is the 10 raised to 4 divided by 10. This is equal to 10 raised to 3. That is 10 raised to 4 divided by 10 raised to 1 is equal to 10 raised to 3. Next is 10 square. It is equal to 10 into 10. This is nothing but this 10 raised to 3, that is 1000 divided by 10. Next is 10 raised to 1. This is 10 and it is nothing but this 100 divided by 10. Next is 10 raised to 0. This explanation is just for showing this 10 raised to 0. How we get 10 raised to 0 as 1? In order to prove this, I explained all these explanations. That is 10 raised to 0 is nothing but this 10 raised to 1 divided by 10 itself. That is equal to 10 by 10. It is equal to 1. So it is proved that any number with exponent 0 or index 0 is equal to 1. This is the proof for 10 raised to or nx raised to 0 equal to 1. Any number raised to 0 is equal to 1. This is the proof for this. Next is 10 raised to, if the exponent is a negative number. What is it? It is just the 0, just left of 0 is negative 1. So we can write this 10 raised to 0 by 10. This is equal to 1 by 10. From this it is proved that negative exponent means we are writing the 10 in the denominator. So again 10 raised to minus 2. This is nothing but this 1 by 10 divided by again 10. It is equal to 1 by 10 into, this is nothing but 10 by 1 itself. So 1 multiply with its reciprocal. So it is equal to 1 by 10 square. From this it is proved that a number x raised to negative n is nothing but 1 by x raised to n. This is another proof. These two exponents can be proved like this. That is, any number, this is nothing but x raised to 0 is equal to any number raised to 0 or its exponent equal to 0 is 1, and any number with negative exponent is equal to 1, its reciprocal, that is 1 by x raised to n. This is the proof for this 0 exponent and negative exponent. So we can write that as the exponent is exponent, that is the index is decreased by 1, the value become 1/10 of the previous value. 1/10 of the previous value. In the case of 10 itself. But if the exponent is like this, 2 raised to n, if here it is, if this n is decreased by 1, then 2 raised to n minus 1. If it is example 2 raised to n, if 2 raised to n minus 1 is equal to 2 raised to n divided by this 2 itself. That is, the base decreased by the value of the base itself. That is the proof. 2 raised to n is 2 times n is 2 is multiplied n times. 2 raised to n minus 1 is 2 is multiplied n minus 1 times. That is, the 2 raised to n is divided by 2. So this is become the 1 by base of the value. We can generally we can write like this. This is the 1 by the base. 1 by base of the value. As the exponent is decreased by 1, the value become 1 by base of the previous value. So we can generally write like this. So next is the law of exponents or indices, and the first law is product of powers. And it is the first law is known as the product of powers. A raised to m into a raised to n, it is equal to a raised to m plus n. Here a is a non-zero integer. A should be a non-zero integer, and m and n are natural numbers. That is the condition. For a given non-zero integer with powers as natural numbers, in the form of a raised to m into a raised to n is equal to a raised to m plus n. Here the bases are the same. Then only we can apply this product of powers law. For example, 3 raised to 8 into 3 raised to 4 is equal to 3 raised to 8 plus 4. It is equal to 3 raised to 12. That is 3 is multiplied 12 times. That is the meaning. If in the case of a root number raised to 5 into root 2 raised to 4 is equal to root 2 raised to 5 plus 4. Here the base are the same. So 5 plus 4 is equal to 9. So root 2 raised to 9. This is the first law or the product of powers. Next is the second law, that is the quotient of powers. Quotient of powers. From the name itself we can assume that is quotient means it is something related to division. So the second law is a raised to m divided by a raised to n is equal to a raised to m minus n. Here also a is a a equal to non-zero integer and m and n are natural numbers. Here also we can write an example, that is 5 raised to 7 divided by 5 raised to 2 is equal to 5 raised to 7 minus 2. That is equal to 5 raised to 5 itself. This is known as the product quotient of powers. That is the second law. From this also we can find out what is a raised to 0. So we already proved that a raised to 0 is equal to 1. So what we can assign to a raised to 0? Another explanation for this a raised to 0. That is based on the second law, that is the quotient of powers, a raised to m by a raised to again m. This is equal to, as per the second law, it is equal to a raised to m minus m. It is equal to a raised to 0. Here a raised to m divided by a raised to m means it is nothing but it is equal to 1 itself. That is any number that is 2 by 2 or 2 square by 2 square. Anything is equal to 1. So here also, as per the second law, a raised to m by a raised to m equal to 1 itself. It is equal to a raised to 0. From this it is proved that a raised to 0 equal to 1. So by applying the second law, we can prove that a raised to 0 is equal to 1. So if we define a raised to 0 is equal to 1, then only this law is true for every natural numbers. This is defined only for, and this is defined only for a not equal to 0. Then only this condition is proved. If a is 0, then a raised to m by a raised to m is equal to 0 raised to m by 0 raised to m. That is equal to 0 by 0. It is not defined. So this law is proved only for a equal to a not equal to 0. That is a non-zero integer. That is the must condition for every law. Next is how we get a negative power. Again, we already proved the same, but here also we can, for a negative power, a raised to n into a raised to minus n. It is equal to a raised to n minus n is equal to a raised to 0, again 0 is equal to 1. This is here, from this it is again we get a raised to 0 equal to 1. If we want the law to be true, when a raised to minus n is equal to 1 by an, then only we get this one, that is a raised to n, that means a raised to n into a raised to minus n is equal to a raised to n into, this is proved only when this a raised to minus n is equal to a 1 by a raised to n. Then only these two are cancel out each other and we get 1. From this again it is proved that a raised to minus n is equal to 1 by a raised to n. Then this law is true for every negative value of n. So we can write like this: a raised to, again it is proved that a raised to negative n is equal to the reciprocal of a raised to n. This is true for every negative value of n. Next is our third law. That is, the third law is a by b raised to negative 1. That is, from this negative 1 it is clear that it is equal to 1 by a by b. As per a raised to negative 1 is equal to 1 by a raised to n. In the same way, a by b raised to minus 1 is equal to 1 by a by b raised to 1. That is, it is equal to 1 by a by b. It is equal to multiplying with the reciprocal, and it is equal to b by a. So a by b raised to minus 1 is equal to, just put the reciprocal. That is the reciprocal, that is the negative power of a given fraction is equal to its reciprocal itself. That is the third law. Next is fourth law. Next is the fourth law, that is a raised to m raised to n is equal to a raised to m into n. And this law is known as the power of a power. So first we can write like this: the fourth law is the power of a power. That is the name of our fourth law, and it is equal to a raised to m divided by n is equal to a raised to m into n. And take an example, that is 7 cube raised to 4 is equal to 7 into 3 into 4, again raised to another power, that is equal to 7 raised to 12. And the next fifth law is power of product. And that is AB, that is two non-zero integers are multiplied and then it is raised to a power. It is equal to a raised to n into, that is separating the non-zero bases and put the power to each of the base. That is known as the power of products. In the case of big numbers we have to calculate, then we can simplify this as a product, that is 7 into 3 raised to 4, and it is equal to 7 raised to 4 into 3 raised to 4. This is the simplest way of multiplication. And the sixth law is a raised to n by power of quotient. The sixth law is power of quotient. That is a raised to n by b raised to n is equal to, again the exponents are the same, so we can write the base in a bracket and put a common exponent. That is 5 raised to 4 by 7 raised to 4. Here the two bases are different and the exponent is same. So we can write like this, 5 by 7 raised to 4. This is an example. And the seventh law is a by b raised to minus n. It is equal to 1 by a raised to, a by b raised to n. And so we can write like this, it is equal to 1 by a raised to n by b raised to n, and it is equal to, that is 1 by a fraction is just its reciprocal, b raised to n by a raised to n, or it is equal to b by a raised to n. So in the same way, a negative exponent of a fraction is the positive exponent, the same positive exponent of its reciprocal. That is the seventh law. These are the laws of indices. Take care, study well. Hope you all enjoyed this video. If you understand easily, please like, share and subscribe. Thank you.